Hi everyone, in the next couple videos I'm going to guide you through solving R and S configurations for a variety of asymmetric centers. Let's start with this one here. At this asymmetric center, we have to fill in where the hydrogen is. If you see the two in the plane of the page bonds in the solid wedge, that means the implicit hydrogen that is not showed is on the dash wedge. Okay? We're going to look at this asymmetric center and assign priority. Initially, we have oxygen, oxygen, carbon, and hydrogen. Hydrogen is 4, and the carbon will be 3. The oxygens will beat the carbon, higher atomic number atoms, because the oxygens are the same atomic number, they tie. And we have to say, now, what are they bonded to within one bond, and what are those attachment points, atomic number? We have carbon versus hydrogen. Carbon is higher priority than hydrogen, therefore we have 1 and 2. So now that we have assigned our priorities and acknowledged that the lowest priority is in the back, we can draw our semicircle from 1 to 2 to 3. That is counterclockwise, and chiral carbon 1 is the S configuration. Okay, let's now clean up our structure, and we're going to move on to chiral carbon number 2. Here's chiral carbon number 2. The implicit hydrogen is now on a dash wedge. Okay. Here's our asymmetric center. The initial atoms connected are carbon, carbon, and carbon. So they all tie an atomic number, but they beat the hydrogen. Hydrogen is 4th priority. Now what you might do is take 2 carbons at a time and compare them. And now that these carbons have tied, initially we look at the direct atomic connections and their atomic number. Here you have this carbon bonded to oxygen versus a carbon bonded to hydrogen, hydrogen, and carbon. Oxygen beats carbon. So we know that this left attachment point needs to be higher than that one, but now let's compare this one to that one. We have, again, an oxygen directly attached versus hydrogen, hydrogen, and carbon. So oxygen beats carbon, that will be priority 1. And now we have to solve for the relative priority of these two, okay? And we had initially on this side hydrogen, hydrogen, carbon. And over here we had hydrogen, hydrogen, and carbon. So those tied. Now we go one further and say, this is now our reference point. What are these bonded to within one bond? Okay, and here you have this carbon being bonded to hydrogen, hydrogen, and carbon. Okay, hydrogen, hydrogen, carbon. This is bonded to hydrogen, hydrogen, and carbon. Again, we're going one bond at a time. Because those tie, we have to go one further to see if there's another point of difference. So now your visual reference point will be these carbons here. And notice how this left side, that carbon is bonded to hydrogen, oxygen, and oxygen, 2 oxygens. And what that's going to do is now beat this other carbon, which is bonded to H, carbon, and oxygen. Oxygen and oxygen tie an atomic number, but now because there's 2 oxygens, this side will win. Now I know this got a little bit messy, but what that means here is that this carbon here is 2nd priority, and this is 3rd. We found the point of difference, and this side ended up being higher priority. This is 1, 2, 3. Counterclockwise, the lowest priority is in the back. What we see is what we get. Okay? All right, let's solve for the last asymmetric center. That would be the last one for this video. Here's the asymmetric center. We have the initial atoms connecting, being oxygen, carbon, carbon, and hydrogen. Hydrogen is 4, oxygen is 1, beating the carbons. Now that the carbons have tied in priority, we have to say, what are they bonded to directly? The top carbon is bonded to carbon, carbon, hydrogen. Carbon, carbon, hydrogen. This other carbon is bonded to hydrogen, hydrogen, carbon. And 2 carbons beats 1 carbon. Therefore, we have priority 2 and 3. Okay, I know that got a little bit messy here, but we have priority 1, 2, and 3. That is counterclockwise, so it looks like it's S. But notice how the lowest priority hydrogen is on the solid. We are going to have to flip what we see, and the correct configuration is the R configuration.